All righty, we are back, and I am excited to introduce our workshop for the afternoon, Explainable Monitoring for Successful AI Deployments, presented by Krishna Gade and Rob Harrell of Fiddler Labs. Krishna and Rob, welcome up and take it away.
Hey, Sam. Hey, everyone. Thanks for taking time to listen to us. We're very excited to talk about explainable monitoring and how it can help AI teams to successfully deploy AI. I'm Krishna. I'm the founder CEO of Fiddler. Here with me is Rob.
Rob Harrell, product manager at Fiddler.
Awesome. Great. Without further ado, we can get started. So let me just share my screen. Cool. Great. Hopefully you can see my screen now. Awesome. So today we're going to talk about explainable monitoring and how it can help AI and machine learning teams to successfully deploy into production today. So the problem with AI, as teams are setting out to operationalize it these days, is most models are coming to be with no visibility and sort of no explainability. They're we call them a black box. When you're trying to sort of deploy the model, there's no good way to understand its performance. There's no good way to monitor its bias or drift, and there's no good way to explain its model behavior. And this is a problem that pretty much every data science team, big or small, that is trying to operationalize their AI is facing. And it's not just affecting the data scientists that are working the model. That's important for them to understand how it's working, whether it's actually working in the same manner that they trained with, but it's also affecting the other stakeholders that your models are consuming. Maybe your IT operations team that is monitoring these models. Maybe your customer support team that is answerable for your model-based products. Your business users who might be consuming the model's outputs. And if it's like a regulated product, such as, if you're working on models for, let's say credit underwriting or recruiting, you may have legal compliance regulatory teams that are interested in understanding whether, model is fair or not. So where are these problems coming from? The problem is that AI is such a complex, system to deploy that most of the times the deployments are error prone. And you can have errors coming from various different places. Your data that you're supplying to the model in production could be very different from the data that you trained with. And it can actually drift over time. We have seen in especially in the last 6 to 9 months, because of coronavirus, many data science teams that have trained models with pre-coronavirus data had to scramble when they saw that their model performance dropped because of data shifts. The user behavior changed, therefore the data started drifting. Case in point, actually, Instacart, a very popular grocery company, blogged about it, where they said that inventory models dropped in performance from 90% accuracy to 65%. And so because we are still not out of coronavirus pandemic, there is this need to when is the next baseline? When is the user behavior coming back to normalcy, and what is the new normal? And so there is, for this continuous drift monitoring, is actually, if lack of continuous drift monitoring is affecting AI systems. The other thing that you can actually suffer from is features. Features can have all kinds of problems. When they are being supplied to the models, they may be missing in values. They may be garbage features being sent by your data pipelines because of errors in code, and that actually affects models. And then model performance decay. Models can actually decay over time. Your user behavior may change organically. Maybe new features get deployed to the models, and overall the model performance changes over time. It can also affect different segments of your population in a biased manner. And ultimately, all of these things will affect your business decisions, because at the end of the day, we're all building AI and machine learning to improve some key performance indicators of your business, and then eventually you might see, for example, like your loans that you're approving a whole bunch of bad loans, or your false positives in your fraud has increased, and whatever business metric that you're working to improve is not actually improving. So the operational risks around deploying AI actually are becoming more and more nowadays. Performance degradation, bias, introduction, data quality issues, not being able to look into how the model is, performing. Why is it performing the way it is? Not having alternative indicators of performance such as drift. All of these things actually make an ML operations team find for solutions in terms of how do they do it. So let's dive a little deep into each of these issues. Let's talk about data drift. This is actually a very sort of a important phenomenon, right? As a data scientist, when I'm training my model and I may have trained the best possible model, and when I deploy it to production, I want the model to perform in the same manner as it was trained, and that's kind of the data scientist's dream. But it seldom happens because your production data is very different, or it could change over time. And if you don't monitor it, then your model performance will also change over time, and it can actually degrade. And so data drift is something that you always have to continuously monitor between your training set and your live production traffic across different features, across prediction values, across just even labels, right? So being able to monitor drift across all of these things is actually super important. Data pipeline issues can affect your model performance. For example, you may have a model, let's say it's a fraud model, and it's receiving a whole bunch of feature data from it. And let's say suddenly a particular feature called whether you're using a credit card in physical location or not went awry, and all of a sudden you're sending bad or incorrect values to the model, and that could really change the model's performance for a particular set of users. For example, one of the banks that we were talking to recently mentioned that because of coronavirus, a certain segment of population that was not using credit cards online were starting to use them online, and all of a sudden all of their transactions were being classified as fraud cases. Now imagine if this was actually not a sort of a real thing, but the data pipeline actually was making incorrect feature data to this model. So that model could be incorrectly predicting for that entire set of population where their transactions could be classified as fraud. And this can happen because of missing values. You can have or range mismatches, right? Like you can have a feature that is out of range, like an extra zero can get added to the income variable for your credit underwriting model, and that could completely change your credit risk sort of score that you would get in terms of prediction. You may have schema mismatches, which can also alter models performance, and they can arise from various different things. They can arise from business changes. Upstream data tables have changed, right? And as a result, your ETL pipeline has not been updated, and therefore your features are sending these bad data, or your data pipeline has bugs, and that could actually result in sort of broken features. The other problem with models is the performance decay. These data drift and integrity issues can affect your model's accuracy, and especially when there is a real change, like especially that one that I talked about, this coronavirus pandemic. Another example is we work with this very large e-commerce company that all of a sudden started people were starting to search for masks on their website at the beginning of the coronavirus pandemic, and so their models were not as performing as well because their recommendations and all were not updated because of this behavior. So if you're not monitoring how your models are performing, and so their CTR went down over time, and so if they actually had a drift monitoring way to actually monitor their models, they could have identified that this was actually going to happen, and they could go and retrain the model and adjust to the new reality. And then bias is another big topic. You can have a model that is very highly accurate over the entire set of population, And then Simpson's paradox can kick in, where you can have different segments within the segments of populations that accuracy might not be as good. For example, you can have a sort of a candidate screening model for say a recruiting agency, and it can be overall accuracy of the model is super high, but then when you look into it, a certain segment of population, the accuracy is not very good. If, let's say, females or applicants coming from a certain region maybe are getting consistently rejected. If you're not monitoring so for such segments, then it's going to be you can this get out of control, and users may complain about your product, and as a result, you may sort of get into either regulatory trouble or some sort of a brand reputation trouble. So how do we solve these problems, right? And so today, machine learning teams are sort of they have very high level monitoring, at the level of business metrics, which they probably are using a tool like a Tableau or a Looker to sort of aggregate the business metrics and look at it. Or they may have some sort of snapshot analysis, how accurate the model is. They may be running some scripts to kind of periodically look into it. What we have built at Fiddler is essentially a tool that looks like a Tableau or a Datadog, but meant for the machine learning engineer, where the object of interest is model, and this tool can be sort of a cockpit view of all the models that are running in production for you in your system, and can give you visibility across all of those model performance and bias, and you can go and explain a particular behavior. For example, if a model is drifting, why is it drifting, which features have contributed to the drift, and whatnot. And overall, teams can set up alerts so that they can stay on top of it. So we call this product an explainable monitoring system for that reason. So the user workflow is very simple. You can actually ingest your machine learning models and monitoring data. You can monitor these models, visualize the predictions, data drift, set up alerts on thresholds that you need to. And when things go wrong, you can come and use explainability features that Fiddler provides to, sort of monitor, to debug these performance issues. And then from there, you can get actionable insights. So you can actually drive performance improvements. Like, for example, whether you have to collect some additional training data sets, or, you have to improve your feature set, or you have to go back and, pick a new machine learning modeling algorithm. So this is how we look at explainable monitoring within the machine learning workflow. So at the very high level, you have this raw data where you're extracting features from, and you're using the features to train a model, and then it gets deployed to production. It's making predictions, right? And then you're getting some label data from your business users and from your end users, whether that's clicks or some human sort of giving feedback. All of this data can be then collected in one centralized system, where you can continuously compute these model quality metrics, compute like data drift metrics, and then look into explanations. And so this is how an explainable monitoring system can enable a feedback loop into the machine learning workflow. So by actually, when you, in terms of how it looks like is, when you deploy such a system, you may get like, for example, hey, here is a drift alert on your email. This particular feature or this particular model started drifting. You can go and click into that alert, and then you can analyze a particular segment of data that is actually affected during this time window, and understand some sort of statistics into what changed there, what features have drifted, which features have changed in terms of distribution. And so this is essentially what we have built. We are going to show it in the next section. Rob is going to present the demo of Fiddler, the explainable monitoring solution, so that we can, in real time, we can see how all of these features come together to solve these operational challenges. With that, I would sort of give this stage to Rob to do his presentation.
Thanks, Krishna. So let's dive into Fiddler to take a look at a real-world use case to illustrate this explainable monitoring workflow that provides AI teams visibility into model performance and behavior, as well as tools to drill down and debug production issues. So we're here on the Fiddler project landing page, and let's take a look at a salary estimation model intended to assist HR teams identify which employees are likely due for a raise. So here we can see in the model detail page, the amount of traffic that's received by this model in production monitoring over time. And as we drill down into it, we can view some of the metadata for the model and the features it was trained on, which include demographic information from these employees, as well as their salaries, years of experience, education level, etc. So the object of this model is to assign a probability. It's a binary classification model as to whether the employee in question should be due for a promotion. And so starting with Fiddler's production monitoring capabilities, Fiddler provides the ability to review and track and alert on performance metrics over time, as well as the ability to observe and dive into production issues such as drift, data errors, and outliers that might cause spurious behavior from the model. So as we can see here, the model is tracking those employees who are due for an upgrade over time, as well as those it predicts should not be due for a salary hike over time. And in addition, the accuracy of the model can be displayed below and alerted on. We can see here in this particular time window, which spans last week, that the accuracy of the model was hovering above 95%, with exception of the time period between January 18th and January 20th, when there was a noticeable dip by about 10% within the model's accuracy. So in the case of an operationalized deployment of Fiddler, an ML engineer would likely receive an email alert or a PagerDuty or Slack notification of this dip, and then be able to dive into Fiddler to diagnose what may have caused this dip in accuracy. So jumping over to the data drift tab, what we can see here is the average prediction value of the model over time, as well as the prediction drift over time in dark blue. So we can see that corresponding to this date range we identified with the dip in accuracy, we're noticing a bit of a spike in the model's drift. So what Fiddler allows you to do for debugging this drift spike is look into the actual component features that might have caused this model level drift. And the way in which we provide this capability is by not only computing and allowing tracking of the features drift over time, but also computing model explanations for each feature, the explainability portion, or the importance of each feature to the model, and combining this drift with the importance of each feature into a drift impact heuristic, which demonstrates or displays which of these features is likely contributing to the overall model drift that we saw above. And so we can see right off the bat that the location of these employees is causing some sort of change or contributing highest to the overall model drift that we observed, which in turn is leading to the dip in accuracy we observed. The years of experience and salaries look to be also potential candidates to investigate. One additional lens we can use to take a look at this issue is data integrity, or the potential for data violations within the incoming production events. And here Fiddler provides insights into potential null or missing values in production events for each given feature, type mismatches, which could be the result of some sort of data pipeline bug, and range violations or mismatches between the training set feature distribution and the distribution of features being observed in production. We can see here that there's been a spike in range mismatches during the time window in question in which we observed the dip in accuracy. And if we drill down, we can see, again, this job location feature seems to be causing some issues, and indeed there appear to be some range violations for it. So what Fiddler then allows you to do is drill down into the actual data to observe what's going on. So in this case, we saw that the job location feature was producing some spurious results. There might have been some violations in the data. Let's take a look in Fiddler's analytics interface to see what might have been going on. So here, what Fiddler provides in this analyze interface is the ability to query the data within the model and produce various types of data visualizations to observe what might be going on. Let's take a look. So we can run this SQL query and query the production data between this time period. And we can take a look at all of the job location data returned. let's go ahead and add a data visualization to it to see what's going on. So I'm going to start with a feature distribution of the job location data. And right off the bat, we can see, okay, there's a range of US employees, there's a range of, or a group of European-based employees, and then there's this lowercase US. Interesting. Well, it turns out this lowercase US is not actually a part of the model's schema. And this is likely the cause of the data integrity violations we saw, and likely also the cause of the accuracy dips that we observed, because the model doesn't know how to interpret this lowercase us. So this is likely the result, or an example of a result that could occur from some upstream interface or UI bug or error that allows for unexpected values to be submitted within a form entry, or perhaps a data processing error where some sort of feature column normalization step is failing in production. So in this manner, you can observe how Fiddler is providing an end-to-end set of metrics to track monitoring performance over time, and then the ability to drill down into the data and understand what might be causing issues when they arise. And with that, I think that we're going to open up to Q&A.
I can help out with that as soon as I get unmuted. There's been quite a bit of chat in the on the platform. The most recent question from Thomas is, how does Fiddler integrate with other existing ML tools and platforms?
So Fiddler is agnostic, actually, to any underlying tools and platforms that might be used for either data pre-processing or model hosting. It's a pluggable tool that can be installed either on-prem in a virtual cloud environment or consumed via SaaS. We have a series of APIs that allow us to ingest monitoring data in production for either streaming or batch models. And we have a very simple Python SDK that allows customers to register their models with the platform. So the integration process is lightweight, simple, and agnostic to wherever their model may be hosted, regardless of whether it might be a managed service like SageMaker or internal platform and tools.
Got it. And how do business users input quote unquote actual outcomes for comparison with predicted actions for the accuracy calculation?
So Fiddler has the ability to ingest label data post facto, and that can be pushed to the system either manually by labelers or in an automated fashion by consuming those label events after the fact. The platform joins those events with the previous prediction and feature logs via a unique ID that can be configured by the customer.
All right, great. There's been a bunch of discussion, and I'm trying to work my way through it to get a sense for what's been answered already.
So I guess there were some questions. Don't you need the label prediction in order to monitor model performance? Yes, in order to monitor the model's performance on the business metrics, we do need the labels, and as just Rob described, you need to log the label. The one thing that Fiddler does support is to asynchronously join your labels with your predictions. So for example, let's say you show a recommendation on an e-commerce website, and a few minutes later or hours later, the item gets clicked or added to cart. You can essentially monitor the performance of the model that way. Similarly, I think there were other questions. For example, what do you do to compare the prediction distribution with training class distribution? If there is difference between them subject to a metric like KL divergence, you could say that there might be a problem. So for to compute the drift calculations, we basically use a metric called Jensen-Shannon divergence, which is essentially a symmetric version of of KL divergence, and that's how we compute the drift. But in order to attribute the drift to different features, we use the feature's importance for the model, and this is where the explainability of the model kicks into it. And so we can actually assign how important is each feature to the the drift that you are noticing. So isn't this assuming IDD? Does this account for feature correlation? So I don't understand what this means by IDD. So if you're talking about attributing feature drift to prediction drift in that context, because we use these kind of Shapley value based algorithms that sort of take into all possible combinations of features to arrive at the features importance for the model. We sort of are able to take into account the features importance in consideration with all the other features that it is involved with. And how can we measure model accuracy without labeling the prediction? I think we already answered that. There are various ways to monitor, measure a distribution. You can compare it to an expected known distribution. Example, KL divergence. Yes, that's correct. For promotion recommendation, it takes a long time to realize that the actual promotions are not matching predictions. Correct. So in certain cases, your label data may arrive quite late. For example, you may have a marketing model that is deciding on which things to promote, and then you would only know maybe a month later or a few months later whether the market promotion has succeeded or not. Same thing happens, for example, in credit underwriting. You may issue me a loan, and until I pay back my first installment, you may not consider this actually a good loan or not. So in those cases, actually drift monitoring becomes very important, because your label data is arriving much later, so you cannot really monitor your model's accuracy in real time. So therefore, model drift monitoring becomes like an early warning system for you to look into if your performance, if your predictions are drifting, then there is a chance that your model is actually not performing very well. So you have to go and look into it. How do business users input actual outcome for comparison? We talked about that. How does Fiddler integrate into existing ML tools and platforms? We talked about that already. It's a pluggable platform, and we can work with most ML platforms out there. Let's see. I think those were the questions for the Fiddler's demo. I'm happy to answer if there are any further questions from the audience as well. Sorry, we just joined late on Umbrella. So. Cool. So I think if there are no further questions, that completes our session. So if you are interested in knowing more about Fiddler, please log into www.fiddler.ai. Oh, there's another question that just came in. What is the largest DL models you have monitored? That's a very good question. So we actually have been working with some recruiting companies that are using deep learning models for processing resumes, and you can think about all the words in the resume, right? Like all the kinds of categories in the resume, all the other metadata that they may have, all become features, right? And so they can be quite large in terms of the feature space, number of words that they're processing, and obviously in terms of number of examples, number of training examples, number of sort of production examples. It can range from customer to customer. Some customer may be having 100,000 model requests per day. Some customer could be having 10 million model requests per day, right? And so we are able to system is scalable horizontally because it's built on Kubernetes. So we are able to add more data nodes to be able to shard and process large amounts of data, and also work for large deep learning models. So another question came in: how are training distributions input into the system? That is a very good question. Today, we ask you to upload your training set when you configure the model for monitoring. So there are 3 inputs to the system. You register your model, you register your training set, and then you start sending your production log, your prediction log to Fiddler. and that's how you configure a particular models for monitoring. And so from your training set, we compute the training distribution for all your features and also predictions. And the question came in, what do you tend to see in terms of deployment, onboarding process in the following dimensions: per model or per or general utility platform, integrated or standalone, what teams involved? It's a very good question. So we generally work with like machine learning platform teams or data science platform teams. Our users are machine learning engineers and data science engineers, or ML ops engineers are the users. And we typically integrate wherever they are scoring their models. So these days there are two broad ways of deploying your models. Either so my model is running as a Spark pipeline in terms of like doing like a batch processing or a bunch of records, right? Or my model could be hosted on a real-time model serving system such as SageMaker or other custom model serving systems that one may have. We can integrate into both places. We can integrate into SageMaker to get all the prediction logs to monitor your real-time model serving. We can also integrate into your batch model processing systems like Spark or Databricks to be able to fetch the logs and then monitor them for you. In terms of how it's deployed, in general, we provide like a centralized service, right? It's like I think about it as a centralized service deploying with n number of nodes that you want, like 2 nodes, 4 nodes, 10 nodes, depending upon the traffic that you get for your models, depending upon the number of models that is configured, and that's how it is priced basically. So those are the questions. Hopefully,
Cool. Last call for questions for Fiddler. Here's one.
Yep. Okay, cool. So a few more. Okay. So if we need to add the data set, does that scale well for very large data sets, big data? Where does the computational distribution happen, for example? That's a very, very good question. So yes, we are meant to process large data sets, right? Because, your training data could be large, but your production data, your monitoring logs could be very, very large, right? For example, one of the fintech companies that we are working with generates, millions of, prediction requests per day. And so we have built the system to be able to take all of the data and sort of and sort of process it and store it. So so in terms of how the architecture is, it's a 3-tier architecture. We have a storage layer which we use like any sort of SQL-based database, like a distributed database, and then we have a processing layer, which is where all the calculations are happening. Drift calculations are happening. Explainability algorithms are also running there, and then we have the presentation layer, which shows you all the UI that Rob showed in the demo. And so that 3-tier architecture can be scaled independently. So for example, if you have low data, but your computations are high, you can scale the compute nodes separately from the data nodes. If you have a lot of data, you can also scale the data nodes, independently. And then another question, is there built-in metrics for computer vision use cases where the inputs are images, brightness, color distributions? It's a great question. Today, our explainable monitoring system works for tabular datasets and text. We don't yet have support for computer vision use cases, which we plan to build it this year. So stay tuned. What model framework formats can you monitor? That's a great question. So today we have customers, monitoring TensorFlow models, Scikit models, XGBoost, and PyTorch models. In general, we should be able to monitor most models because essentially we're looking at the inputs and outputs of the model, right? We should be able to like monitor any of these, models, even some of sort of old school models that we may not have runtimes for. Great. A lot of teams are thinking about explainability. Can you elaborate on the build versus buy consideration? It's a great question. So what does explainable monitoring really mean, and where does explainability, sort of help with monitoring today, right? So imagine you are sort of a fintech company. You're having underwriting models, and they're running in production, issuing loans, determining good versus bad loans, right? And you want to sort of when your let's say your bad loans are increasing over time. Your CEO or VP of product might ask you, hey, like what's going on? These our false positives are increasing, or bad loans are increasing, or our loan collections are dropping. What's going on? Today, our monitoring, most of the monitoring stays at that level, the business metrics level, With tools like Fiddler, what you get this advanced capability to understand, okay, why did that sort of loan collection drop? And you can look at whether model performance was changing during that time. And let's say if there was actually a prediction drift that you observed, or a model drift that you observed, then you can dig into which features were actually causing that drift, and then attribute those things, and then go into subsections of it to understand what changed during that window. Is the model started not doing well? These features have shifted dramatically, and then you can start taking actions. Maybe it could be a data pipeline error, as we discussed. It could be like user behavior change that you did not anticipate. If this is consistent, then you may have to ask the data science team, hey, this model behavior is changing in the last few days. We have to go back to the drawing table and retrain the model, and add some more training examples to be more representative of what's happening in production. So all of that insight is what is provided by this tool, and that's where explainability helps us. Talked about experimentation and experimentation platforms today. What's the relationship between experimentation and monitoring? That is a great question. So traditionally, experimentation so far in machine learning has been mostly around training process, right? So it's determining, running lots and lots of experiments, like experiments meaning training pipelines, so that you can pick the best possible model to launch to production. So a lot of experimentation workload has been to be able to launch like these hyperparameter tuned sort of pipelines, training pipelines, so that you can select the best possible model. With monitoring, what it enables you is to do some of these challenger champion testing, challenger champion model performance analysis in production. So let's say I have a fraud model already in production. I may have a few challenger candidates that are already ready to go. They're all pretty good in terms of accuracy, but I've not tested them in production data, right? So that's what you can do with a tool like Fiddler. Is you have a production model that's getting this type of accuracy. It's not having so much drift or whatever, and you're trying to insert a new challenger model and a few challenger models that you can compare one against each other in terms of how it's performing and how it's not performing. So yeah, so it's like more user facing. It gets into that more production sort of experimentation side. What are the most common use cases where XAI and monitoring are most useful? What are the biggest customer need today? As I said, AI systems have all of these operational risks today, right? If you don't monitor, you're flying blind. Your model could drift and your business metrics could go down. This actually could be a biggest risk, right? Your business metrics could be going down, and you may not know why that is. Or even if you know that your business metrics are not going down, you may not know what to do, where your model is actually affecting them. That's number one. Number two is, if certain segments of users are actually being adversely affected, because of model performance issues, then you could get into model bias concerns, which is like a huge thing for certain kind of companies. And then in cases where your actually model is underperforming, a lot of people within your organization might want to know why that is the case. Why are these people not getting the loans approved? Why are these candidates not getting approved by your recruiting models? And those questions, typically what will happen is the data scientist will have to say, okay, get me all of the last week's production log data into a data frame in my notebook. Let me create some import a Shapley value sort of library, and then analyze it myself, create some charts, and then then share it in a PowerPoint, and then present it to my product leaders and whatnot. This is what is happening. This is what you're observing. All of that is being packaged for you into a platform, so that a data scientist doesn't have to spend time doing that. You could just come and with a few clicks you can get that insight. You can also share it with your ML engineers or business analysts and other people as well. How can Fiddler help a retail or e-commerce brand increase revenue? Yeah, so machine learning is, people are employing machine learning for personalization, for promotions, for identifying the right item to be delivered at the right time to the right user, right? And that's the kind of the holy grail for any e-commerce or retail, to be able to sort of solve that problem. And people are trying various different machine learning algorithms today. What Fiddler can help you is to essentially help you launch the best possible models to production, by monitoring them continuously, by being able to sort of ensuring that their performance stays stays sort of on top during and so it essentially prevents revenue loss. And then when you're launching a new model, it helps you to understand how the new model is working as opposed to the status quo, and then see where opportunities are for you to improve the new model and see if it's actually better than the new old model or not, and so that you can actually improve your business metrics. Hopefully that answers the question. So I think there was another question. If you have a few more minutes, I think Sam asked, build versus buy considerations. I think mainly what we are trying to solve is all of the stuff that we showed you is something a data science or machine learning engineering team can build. This is not rocket science, right? All of these tools are available. You can put together, you can build it. What we are providing is a packaged service, a platform, so that the data scientists and ML engineers don't have to do it, and they can focus on their core job, which is to build machine learning models, to train the best possible models, and to figure out what features that they need to include for their models and whatnot, which is what, if I were a data scientist, I want to spend most of my time there, not on building monitoring infrastructure and analysis systems. And that is what we are out there to do, to help the data scientists to get this sort of in place so that they can spend less time. In fact, one of our customers mentioned to us that their debugging time for model performance issues dropped from 3 days to less than an hour for their data scientists. And it's a huge productivity gain for teams. So another question, where do you see bias and fairness play a role within AI observability, and do you think it makes sense for companies to begin thinking about it? Absolutely. I mean, I think as more and more people, especially the general human society, is getting aware of all the ethical concerns around AI, genuine concerns sort of coming together, right? And the obvious use cases that we are all familiar with is, is my lending model fair across all the populations? But then it's going beyond those obvious use cases. For example, recently, a delivery logistics company out of UK called Deliveroo, they got sued by an Italian court that they were actually issuing delivery sort of orders to their delivery personnel in an unfair manner, right? And so certain people are getting certain timings that were perceived to be unfair by them, and so these are types of use cases that people did not think about, right? And so now anywhere the algorithm is touching a human, right? There are concerns whether it's actually biased, whether it's actually fair and equitable. And at least one thing that people should start doing is to be able to monitor it, to be able to understand what's going on, so that you can stay on top of it and sort of address it to whatever extent we can address it.
I'm going to keep coming back on, because every time I come back on, you get
there
more
will be questions. Yeah. Right. Oh, Sam, do you have any questions?
I put mine in the chat with
everyone
else.
That's right. You did already. Yeah, correct. Right.
Awesome. Well, if there are no more questions, here we go.
There you go. Okay.
I'm your good luck charm, Krishna.
Okay, cool. What do you think about the future of AI? Where do you see opportunities for monitoring to increase transparency and actionability? See, I think we are we built the company around this mission to build trust into AI, right? So we believe that things like explainability, monitoring, and bias detection are super important for companies to deploy AI in a safe manner, in a trustworthy manner, both for themselves, so that they actually know if the models are performing very well for their own business metrics, but also for their end users, so that they can continue to build trust and ship trustworthy products for their end users. So we believe these are extremely critical for AI's adoption to grow in the future. And that's what we have set out to. So we want to build this platform so that every company, every team that's actually productionizing machine learning and deep learning models can benefit from this technology and sort of safely deploy their models to production.
Awesome. Well, Krishna, as always, great seeing you, and thanks so much for your presentation and for taking so many questions. And thank you as well, Rob.
Absolutely. Thank you so much, Sam. And it was a great pleasure being on TWiML. Thanks, everyone.
Thank you.
Thank you. And thanks, everyone. That concludes our day at TWiMLCon. Tomorrow, we will be back at 9 a.m. Pacific sharp for a full day of workshops. Our first workshop will dig much deeper into the presentation by the Splice Machine team on how to really reconsider your model workflow around a database. And then we'll be talking about AI and mobile platforms. And we will conclude the day with a discussion and demo of incorporating simulation and synthesized data into your model development workflow with Unity. See you all tomorrow.